This is Algebra 1, Lesson 4H, a review of operations with decimal numbers. So specifically with our decimals here. And they give you a little bit of a pre-example, I guess, here in the textbook. They have this number, which I would say is 1 and, that would be 5. Here would be tenths, hundredths, thousandths. That's 1 and 5 thousandths. And then here you have 300 and 12 thousandths. And we're going to add those together. And the text tells you to line up the decimals when you add or subtract. So we're just going to make sure the decimals are lined up, and they are. And then we add, bring down the decimal. And you've done this before. Have you ever thought about why you line up the decimals there? Because later, when we're multiplying in just a little bit, you're not going to line up the decimals. So why do we have to do it here? Well, I think it's helpful to think about money. What is $10.25 plus $1? Can you think of that answer in your head? $10.25 plus $1 more. Well, I'm going to put some examples up here, some answer choices, and you pick the one that you think is right. Which of those is right? Would you put the 1 here? Or would you put it here? Or would you put it here? Or would you put it here? Which of those is the right way to do it? Well, if I do it like this, that's acting as if that 1 is not a dollar. It's acting as if it's a cent. And if I put it here, it's acting as if it is in the tenth spot, so it would be 10 cents. If you put it here, it's a dollar. Let's hold on to that one then. And if you put it here, it's a 10. It's as if it were a $10, because that's what this 1 in that spot represents, is 110. So we have to do it like this way. And we know that when we think about money. So we have to think, well, where is the decimal in $1? If you say $1, there's the decimal. And that's why we're going to put that 1 underneath the 0 in the $10.25. So if you're adding and subtracting decimals, think about money. Example 4.1. Add these two decimals. Now, these decimal numbers are bigger than our common use of money, right? You see gas prices that go an extra place value, I believe, don't they? But we can still apply the same thing. I'm going to copy that one down, and then I'm going to take this one, and I'm going to start copying. I'm going to make sure the decimal lines up. Okay, so I'll put a 0 in front of it, and then start copying from there. 0, lining them up. 2, 1, 6, 3. Now notice how this 3 isn't under anything. Okay, the second number is longer than this first number. Well, we can always add zeros once the number's done. We can add as many zeros as we want, right? Or you can just leave a blank space there if you would like. I'm going to be adding, so it's safe to leave a blank space if you'd like. I like to make it nice and even. So now we're going to add those up. Oh, I put the decimal in the wrong place. Sorry about that. 2, 0, and 4. 4.02323. Let's see how we would read that correctly. This would be tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this would be 4 and 2,323 hundred thousandths is how you would read that. And this would be our answer. 4.2, subtract this number from this number. So let's write what we're subtracting it from, because that's probably the trickiest part here. You're going to see that, and it changes the order a little bit. Like if I say subtract, this is a side example, 5 minus 2. Well, you just do 5 minus 2, right? But if I say subtract 5 from 7, then you wouldn't do 5 minus 7. The from says I want you to take the 5 from the 7. So I want you to turn it around. That would give me an answer of 2. So when you see that from, it's changing your order a little bit. So this number is going to go second, and this number is going to go first. So let's write our first number, 4.0016 minus 0.02163. Now, we see here again, we've got a space here. Now, when the addition, we just left it a space, and that's fine. But here, I've got to take 3 away from something. So I need to think of that as there's a 0 there. Okay? And then, how do I do this? Well, I can't take 3 away from nothing, right? So I'm going to end up borrowing. And if you take one of these, it's down, and this one goes up. And then I can't do this one, so I'm going to have to go over and borrow. And this one goes up. And then this one can't do it, so it goes, but it can't. They've got to go way over here. So, and then that gives to this one. But then he gives 1 to this one. And then he's got to give 1 to this one. It's like neighbors on a street. And they're like, hey, I don't have enough. Can I have some? Right? And they go all the way down and borrow. All right, now when I subtract that here, I've got 7, 9, 9, 7, 9, and then a 3. So I got 3.97997. So that would be tenths, hundredths, thousandths, 10 thousandths, 100 thousandths is what that is. And there's your answer. 4.3. Yes, there it is. 4.3. When we multiply this, they gave you in the book the time symbol with an X. They're still doing that some. I'm going to rewrite it with parentheses, okay? Just because that's what they told us to start doing, is to not use the time symbol as an X as much anymore. And that's okay if you still are, but because we're in algebra, we're going to be using X as a variable. And so we're not going to want to use that as our multiplication symbol anymore. All right, so when you're multiplying, think about money. Got a little side example here. Do we have to line up the decimals to multiply? Okay, do I have to do it like 4.06, 0.016, or something like that? Do I have to line those decimals up to multiply them? Well, let's take an example of money and see how it works. Sometimes when I have trouble knowing how to do something in math, I think, well, is there an easier example that I could do? And sometimes I just make up an easier example and I try it and I see what I learn from it. All right, so if I'm going to double $1.75, how would I write it? Would I do $1.75 times 2 written like that, times 2 written like that? Well, with multiplication, I would still do the same thing. I'd double that number, carry, double that number, carry, double that number, right? If I wrote it here, I would do the same thing. So it really doesn't matter. But what we do need to think about with multiplication is, where do we put the decimal? How do we know where we're going to put the decimal? So let's do this example, $1.75. And we're going to double it. I'm just going to put the 2 down here. 2 times 5 is 10, carry the 1. 2 times 7 is 14, plus 1 is 15. 2 times 1 is 2, plus 1 is 3. Now, if I'm doubling, think about this reason here. I've got $1.75, and I'm doubling it, okay? Maybe I want to buy something in the store that's $1.75, and I decide I'm going to get 2 of them. Should I expect that I'm going to be paying $350? No, that's not reasonable, is it? Should I expect that I'm going to be paying $35? No, that's not reasonable. Should I expect I'm going to be paying $3? Yeah, that's a little more reasonable, right? Because this number is less than 2, and if you double 2, you get 4, so my answer should be less than 4. So I see, just reasoning it out, I should have $3.50. So how can I do that? Well, it's not bringing it straight down, because there are other factors that could change that, where it goes. Here's your rule for when you're multiplying by a decimal. You count how many digits are after the decimal place. So here's my decimal. I have 1 number here, 2 numbers here, and here's a decimal, but there's no numbers after it. So I don't have to count anything there. You could put zeros, but it has to be another digit after it, unless it's, well, we'll get to that later. But we're going to count how many are after the decimal. So here we've got 1, 2. So I'm going to go 1, 2, and I get $3.50, which I know is a reasonable answer. Okay, so now when I do this problem, I like to put the longer. Doesn't necessarily mean it's the bigger number, the one with the greater value, but I like to put the longer one on top. Okay, I do, when I write multiplication like this, still use an X because this is an arithmetic thing, right? There's no variable. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 6 times 0 is 0. 6 times 0 is 0. And then when I multiply by this 0, I'm going to move in 1. Okay, so add a 0 because I'm multiplying by the tens place. And then I move in 1, and then that's going to be all zeros. Okay, so I don't really need that row, do I? I just know it's going to shift over. Now I'm going to multiply by the 4. I've got to have 2 placeholders. And then I'm going to multiply by the 4. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. 4 times 0 is 0, and then 4 times 0. Now I'm going to add all these up, and then I'm going to put a 6, a 9, 4, a 6, zeros there. How many numbers behind the decimal? Okay, this 0 is trapped, so we count it. 1, 2, 3. Then we go 1, 2, 3. So our answer is 6.496, which is 6. And, oh, I'm sorry, I counted wrong, didn't I? I just realized our answer is not 6.496. Look what I did. What else did I not account for? Can you find it before I say it? When I counted my number of numbers behind the decimal, there's 1, there's 2, there's 3. But this part of the problem has numbers behind the decimal as well. And it's got a trapped 0. So here's 1 and 2. So I've got 1, 2, 3, 4, 5. So let's fix my error here. It's not terrible when you make an error. It's only terrible if you don't fix it, right? Okay, so let's go 5 places. 1, 2, 3, 4. I'm going to have to add a 0 so that I can go the next spot. I'm going to put an initial 0 placeholder. Okay, and this is the number I get. Let's think about the place value. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. So 6,496 100,000ths is the answer that we get. All right. And then we have one more here where we're going to divide. Okay. Now we talked earlier about how division can be written with a bar, a fraction bar. And so what I did was I wrote this problem 2 different ways. One, I wrote it like a fraction, and one, I wrote it the way you're used to seeing it, okay? Now, let's look at it as a fraction for just a second. When you have a fraction, like we mentioned earlier, like let's say 2/4, it is okay if you divide the top and the bottom by the same number, or multiply the top and the bottom by the same number, okay? Because you end up with this, an equivalent value. Well, we can do that same thing. We can apply that here. If I really don't want to divide by a decimal, that's kind of difficult, but I can divide by 3. So what could I do to make this a 3? Well, let's multiply this by 100, because multiplying it by 100 will bring it 2 places. But if I do that, I have to do the same thing to the top. So let's move it 2 places. Okay, so then I can apply that same thinking here. 2 places, 2 places, and then bring it up. Then I can do it. And if it's a little messy to you and you don't want to, you don't have to have those zeros now. If it bothers you having that kind of mess in there, 603.9, you can rewrite it where the decimal is after we've adjusted it and go ahead and bring it up. 3 into 6 will go 2 times. Bring down the 0. 3 won't go into 0, so I'm going to put a 0 up. Bring down the 3. 3 will go into 3 1 time. Bring down the 9. 3 will go into 9 3 times. And so I get my answer, 201 3/10 is my answer there. So that is our review of the operations of arithmetic that we can also use in algebra.